Hello dear students, welcome you all to Sri Vidyaniketan Public School online chemistry classes. Today we are discussing about reactivity series. So which is most important while writing your displacement reactions or double displacement reactions. Based on the reactivity of the elements we are going to write the equations or reactions there. Then when you come with the reactivity series, the arrangement of elements in the vertical column in the decreasing order of their reactivity is called as reactivity series. So we do have different reactivity series like reactivity series of metals and reactivity series of non-metals. In place of this element, if you are taking out and put the metal, the arrangement of metals in a vertical column in the decreasing order of their reactivity, is called as reactivity series of metals. Okay, then how this reactivity series can be written? So that will be depending upon the reaction of the elements which is going to react with oxygen or water. So in that water only, again the cold water, hot water, like that, which is most reactive element in the oxygen, that will be kept as a first position. It will be at the topmost. Okay, and the element which is least reactive, that will be below to the reactivity series. So see, in reactivity series, the first element I am taking as potassium, then sodium, then calcium, then magnesium, aluminum, zinc, iron, tin, lead, then hydrogen, which should be written in the bracket, then after that copper, then silver, then mercury, then gold. So like this reactivity series should be written with a downside arrow mark. So that downside arrow mark will show that it is in decreasing order of reactivity. So here potassium, sodium, calcium, these will react with oxygen very easily. Okay, they are readily reacts with oxygen and they catches fire. Due to that, we can say those are called as most reactive elements. Even though they readily react with the cold water, easily they will react with cold water. When you come with magnesium, aluminum and zinc, these will react with hot water. Okay, so the reaction of magnesium, aluminum, zinc, these will not react easily with cold water, but they will react with hot water. So little bit they are less reactive when you compare with potassium, sodium and calcium. Then iron, tin and lead, these will react with steam. As you know, steam is nothing but it is the gaseous state of water. When water is in gaseous state, that we are calling it as a steam. Iron, tin, lead, these will not react with even hot water, they will react with the steam, the water which is in the gaseous state. Then after that you have hydrogen. So you will have a question, hydrogen is non-metal, then why we have kept in the metal series? So I was saying that hydrogen have an ability to lose electron. By losing, it will lose electron. By losing electron, it form positive charged particle. Okay, if positive charge is there, it is nothing but metal, just it will shows the property of a metal. So due to the formation of positive charge, hydrogen is kept in the metal series. Then after hydrogen we have copper, silver, mercury and gold. So all these are low reactive elements. Okay, and these low reactive elements except copper and mercury, just they will be not in a combined state, they will be in free state. Okay, and these are high reactive elements. The elements which are above to the hydrogen are high reactive elements, they will be always in the combined state. We can say, see, up to zinc, from potassium to zinc, those are most high reactive element. Most reactive are high reactive elements. From iron to lead, we can say these are moderate reactive elements. All these are moderate reactive elements. And the copper, below to that, these are low reactive. The elements which are below to hydrogen, all those are low reactive elements. Then what is the use of this one? As I was saying, suppose a simple displacement reaction, copper sulfate is there. To this copper sulfate I am taking iron. Okay, so copper is below to hydrogen and iron is above to hydrogen, which is above to copper also. When it is above to copper, so in the arrow mark what I said, all the elements are arranged in decreasing order. Iron is high reactive than copper. Due to that, iron have an ability to displace copper and it will become iron sulfate with the deposition of copper. So like that, it will be helpful while writing a displacement reaction. Hope you understood. A reactivity series of metal is nothing but it is an arrangement of elements, arrangement of metal in the decreasing order of the reactivity series in vertical column. Even though you can write with the increasing or decreasing signs also, that one also is correct only, but always it is better to write, it is easy to write in the vertical column only. Even though we have the reactivity series of non-metals like fluorine, chlorine, bromine, iodine. This is a reactivity series. Fluorine is high reactive and iodine is low reactive in nature. Okay, let us go with next one. Electron dot structure. Electron dot structure is the representation of valence electrons in terms of dots. The representation of valence electrons in terms of dots around the symbol is called as electron dot structure, or we can call it as Lewis dot structures, even though it is also called as valence dot structures. So like that, this valence electrons is mainly identified by using your electronic configuration, what we have learnt already in the last classes. So based on those valence electrons, we are going to keep the dots around the symbols. For example, see, look at here. If you are taking magnesium as an example, if magnesium is there, so this magnesium is having atomic number 12, and write the electronic configuration 1s2, 2s2, 2p6 and 3s2, which is outermost shell here. 1s is K shell, 2s and 2p is L shell and 3s is M shell. The outermost shell is here M shell, and how many electrons are present? 2 electrons. The electrons which are present in the outermost shell of an element is called as valence electrons. The electrons which are present in the outermost shell are called as valence electrons, and these valence electrons are used to denote electron dot structure, which is useful to identify the type of bond which is taking place in between any element combination. For example, how many dots are there? 2 dots or 2 electrons. So write the symbol of magnesium with that 2 dots around it. Okay. Suppose oxygen is there. Oxygen atomic number is 8, and try to write the electronic configuration 1s2 and 2s2, 2p4. So here outermost shells are 2s and 2p. Total valence electrons are 6. Valence electrons are 6. So take oxygen symbol and denote the electrons around the symbol. So 1, 2, 3, 4, 5, 6, 6 electrons. While writing the electrons, while denoting the electron as a dots, if the electrons are more than one, try to write it in a pair manner as I have written on the board. So after this, what happens? See, these electrons, if it is donated, this will having outermost shell L. Magnesium, if 2 electrons are donated, the outermost shell will be L, and it will be attaining 6 plus 2, 8 electrons. That in the sense, it will go for stable state. So here 4 plus 2, 6 electrons are there. It combines, it takes 2 electrons to go for stable structure. So like this, we are going to denote the valence electrons which are present in the shell, outermost shell, as a dots. So this is nothing but electron dot structure. Then what is the use of this electron dot structure? By writing this, by writing the dots around the symbols, we can easily identify whether the element is going to donate the electron or accept the electron or share the electron. By using these dots, we can identify the bond which is taking place in between the 2 elements when they combined together. The bond which is taking place in between the 2 elements when they combining together. So like that, it is very useful to identify the bonds in the compounds. Clear? So this is about electron dot structure. So in this class, we have learnt about reactivity series and electron dot structure. Reactivity series is an arrangement of element in the decreasing order based on their reactivity, and that will be useful while writing displacement reactions. And electron dot structure is the representation of valence electrons as a dot in terms of dots around the symbol, which is useful in identifying a bonds or type of a bond which is present in between the two atoms when they combine together. Okay, hope it is useful to you. In the next class we will discuss about the formation of ionic bond and the properties of ionic bond.